Well, hi all, it's John, the founder of John Academy once again, and today we're going to focus on the transformation exercises of the Regents Geometry August 2025 exam. So for this first exercise here, they are telling us we are doing two transformations, one after the other. The first one is going to be doing a 90-degree clockwise rotation. So we are going to transform from xy into y minus x. So as we can see, B is gonna come around here, no? Because it's, we could say 2 is gonna come to minus 2, or it's gonna be coming to 2 minus 2, no? So around there. Then G is the outermost, so it's gonna be also here. Then D has more Y than X, no? So the Y is gonna become our X, and then minus whatever we have for the X. So it's gonna be somewhere around here, no? So that's gonna be D, and the other one should be around here, no? Which is F. So more or less we are getting here. And the next transformation is even easier because it's a reflection over the y-axis. This means we are reflecting over this line, no? So M is gonna be the B. P is gonna be the F, as we can see. So what we were asked was BD. BD is this one. It's going to become MQ. So we are going to go for the third option. And at the same time, this matches BD MQ. So it's good. Something else we can check for this exercise will be checking the three transformations, as we can see here by graphing. So BD came firstly here, and lastly, it became this one here. So we were good, everything good. Now let's jump into the next exercise here, no? So we have two triangles, and they are asking which transformation happened, no? Maps one into the other. So let's see first both reflections. First reflection is y equal to x over y equal to x. This will be this line. And if we are reflecting over this line, D will have stayed there because it's on the line itself. So this one can't be, no? We can discard it already. Second one is y equals to minus x. This one would be this line and looks more promising at first, no? Because, for example, D is here 2 in diagonal and 2 in diagonal to the same or to the opposite distance, no? So D is good, reflected, but as we see, E is not correctly reflected with F, no? So this one can't be either, second option. Let's jump into the next one now. Let's erase this here. The last one, or the next one we can try is the last one, no? Because it's a translation. These ones are very easy to check. So 4 units left and 4 units down. So 4 units left from D is here and 4 units down is here. So D into D prime is good. Now let's check E, for example, because all 3 points have to be transformed under the same transformation, no? And E doesn't work either, and F obviously doesn't work. So it's only one of the points, so we can discard the last one, and it will be a reflection through the origin. Why is that? Because the origin is this point at 0, 0, and we are at the same distance here, reflected, and then E, we can check, is also the same way around, and F is also the same way around. So it will be the third option here. We take that one. Now let's jump into the next one, number 17 here. This is a dilatation. So let's see. What are the coordinates of the center of this dilatation? It's dilated by a factor of 2, no? So we can try the different points. For example, 0, 0. What do we see here? This distance, that one, to B, has to be the same as, as to S, no? Which doesn't work, as we see. Then 0, 0 is already discarded, the origin. 3, 3 is where B is located. So it's gonna be impossible to move anything from B. B will have stayed the same point, no? S will have be equal to B, so that doesn't work either. 3, 3. Then we have 1 minus 1. 1 minus 1 is over here. And we can check now this distance, no? And then into R, which doesn't happen. You see, it's not in a straight line. And same way with the other points. So this one wouldn't be the case. 1 minus 1. And now we can check the last one to make sure it's working. We can also erase this. Last point is 2, 1, which is here. And from there, we see that if we go 2 up and 1 to the right side, we get there, no? To B. And if we go double, so 4 up and 2 to the right, we get to the S, no? Here is going 4 up and 1 to the left. Here is 8 up, 2 to the left, no? So double. And here is also double. So as we can see, the answer is 2, 1 there. Very good. Let's see now number 21. 21, they are talking about a dilatation of a scale factor of 3. So that means that x prime is going to be 3 times x and y prime is going to be 3 times y. So now we can solve for x and y. So x will be x prime divided by 3 and y would be y prime divided by 3. Now we can plug that into this formula, the original line, and see what happens, no? So 4 times x prime divided by 3 minus 6, and then instead of y, we write y prime divided by 3, and this equals 24. And now if we expand the whole thing here, what are we getting? 4 thirds x prime, and this 6 divided by 3 or minus 6 divided by 3 is going to be minus 2y prime equal 24. What happens? None of the equations look similar to this one because we have a 24 here, but we are very close. We just have to divide everything by 2, no? Both sides of the equation. And this is going to get us to 2 thirds x prime minus y prime equals 12. And now, what can we see? The first option really looks very similar. We just need to rearrange the equation. So the y prime, we move it to the right, no? And the 2 thirds x prime, we leave it here, and minus 12 becomes negative, no? So it's gonna be the first option there. Let's check now this next one that has to do with a rhombus, no? Which transformation does not carry the rhombus onto itself? So let's check first the reflections because are kind of the easiest. Let's draw both lines. So 1/2 is here, and then a slope of 1/2 takes us also there, no? So we have 2 points. We can draw the line already. It's gonna be the line that goes through those 2 points, more or less, like that. So this one, obviously, these 2 points, as they are in the line, they stay there, and these 2 are reflected, no? So that one works. So it doesn't, it can't be the answer, no? It leaves the rhombus as it is. The other line, the other reflection we can draw will be 2 the y-intercept and minus 2. Minus 2 brings us there, no? As the slope. And that one is also this other one. So this one also leaves these ones fixed, no? As they are in the reflection line, and the other 2 flips them, no? So this one wouldn't work either. It leaves the rhombus as it is. And then we can see that 1, 0, the one here, is this point. So a rotation of 180 over 1, 0 as being the center, in, so to say, from this rhombus, is gonna leave it as it is. Yes, now let's just check the first one is correct. So a rotation of 180 around the origin is xy, coordinates xy go into minus x minus y. Therefore, we can take one of the points here, which is 3 minus 4, and this should be going to minus 3 and 4. which doesn't exist over here, no? Minus 3, 4, no, sorry, it will be here. Either way, it's not there. So that wouldn't be a rotation or a transformation that brings the rhombus onto itself. Is the first option here. Now let's go with number 24. This one is fairly easy. They gave us a square with an area of 36. So we can draw a square just as reference. And they tell us is dilated by a scale of 1/2. This means each of the sides becomes half, no? Okay, so we can check here, no? This one has an area of 36 and we are asked the area of the smaller one. So what happens? The sides became half. And there is a rule that tells us that the area is gonna become the scale, no? 1/2 a square. And if it was a volume involved here, if there was a volume, it will be cube also. The ratio or the scale cube for the volume. So in this case, 1/2 square is gonna become 1/4. So it's 36 times 1/4, no? And the only option for that would be 9, which is the first one here. So we got that one. And now let's check lastly this one here, no? So we have triangle DAN, so we can draw it here. D, we can draw it here, A and N. And is translated. So translated, it will be by a vector, no? Somehow we are bringing the 3 corners of the triangle into something like this, no? And the new vertices are D prime, A prime, and N prime. They are corresponding. So what can we see here? The 3 sides, the 3 side lengths are preserved. So we can apply here directly the congruence criteria of side, side, side. And both are congruent. So we could write triangle DAN is congruent like that to triangle D prime, A prime, N prime because of side, side, side congruence criteria. So that has been all of the exercises around transformations for the exam, and we see us in the next one.